chem-house.com.
Okay, students, today we are going to start with the topic salt hydrolysis. Okay, so before going for the salt hydrolysis, you should know about the types of salt. Okay, so normally what you study in other books or most of the basic books, you will study about the four types of salt. Okay, depending on the products of hydrolysis. Okay, what you study is types of salts based upon the types of salt only based upon the salt hydrolysis. They are divided into salt of. Okay, up to here it will be common. Up to here it will be common salt of strong acid and weak base. Okay, first will be SAWB. SAWB means salt of strong acid and weak base. And second will be salt of weak acid. We can take weak acid, but this time we will take strong base, WASB. Okay. And third type we are going to study is salt of weak acid, and weak base. Okay. So here both are weak. Understood? This is most important out of these three. And fourth one will be salt of, okay, next one will be salt of strong acid and strong base. And you might be thinking this will be more important than that, but it is not important. Okay, this is not important, salt of strong acid and strong base. Because why I am saying not important? Just because there is no hydrolysis at all. Okay, there is no hydrolysis at all. So what is hydrolysis, what is further, that we will come to know. But before going for the salt hydrolysis, and there are certain types of salt which are not covered in the most of the books but very important. Okay, that we are going to study. Okay, so first type of salt which we come to know, which we study, first type of salt. This is normally covered everywhere and you will also find in the most of the books. Okay. So first type of salt we are going to study is simple salt. First type of salt we are going to study is simple salt. Okay. So further simple salt are further classified. Further classified. Simple salt are classified into, first of all, normal salt. Okay. I will be giving example each and everything. Normal salt. First type will be in the common simple salt is normal salt. Okay. Next one is acidic salt. What is the next one? Acidic salt. Next one is basic salt. These are all these are all types of salts only. Don't think that acidic means it will be a part of acid. Okay. So no, it is just a part of salts only. Okay. They will be basic salt. This is also salt and this is also salt. Acidic salt and basic salt. Okay. Now next one, after the acidic salt, normal salt, basic salt, these three comes under the a simple salt. Okay. So these three comes under what? Simple salt. Okay. Now we are going to study another type of salt which is not under these three are the simple salt. Next type after the simple salt, then it will be double salt. Okay, double salt. Once I take example and you should be able to, there will be definitely a question based on this. What type of question? Identify. You will be given a salt, it comes under. Otherwise, this is an example of, okay, acidic salt. Which of the following is acidic salt? Like that, understanding must be very much high. Okay, double salt. Then third type will be complex salt. Third type will be what? Complex salt. Complex salt. I think You might have come across these type of salts, but not all together. I am not taking something which is out of the syllabus. It is within the syllabus only, but problem is that it is studied somewhere else. You will not be able to recollect that time. Okay. Fourth type is mixed salt. Fourth type is mixed salt. Once you understand all these four type of salt, then your topic, then this topic you can understand. Okay. So normally you will be taught like directly this one. So these are all we are going to study now. After that we will be going through the types of salt and based on the salt hydrolysis. Okay. So first of all, what is simple salt? Let me change the color. Okay, simple salt means any salt. Simple salt means salt made up of one acid, one type of acid and one type of base. Any salt which is made up of one type of acid and one type of base. Okay. So let me take an example, then you will come to know NaCl is a salt. NaCl, to make any salt, we require one acid. For making the acid, what we will take? We will take HCl as an acid and NaOH is a base. Okay. So NaCl is made up of a simple acid HCl and simple base NaOH. That's why it comes under the simple salt. And in that also, there is it comes under the normal salt. Understood? So whatever the example I am taking individually, acidic salt, basic salt, they are all part of the example of simple salt. Okay. So simple salt, is it understood? Salt formed by neutralization part between acid and base. Okay. So this comes under the normal salt. Now here once we say acidic salt, that means some acidic nature must be left over. So these type of salt you can form only from the polyprotic acid. You can find only from the polyprotic acid. Okay. So polyprotic acid, first of all, you should know about the polyprotic acid. What is polyprotic acid? Any acid whose acidic nature, whose basicity is more than one. Like HCl cannot form the acidic salt, but H2SO4 can form the acidic salt because it is a diprotic acid. So this will undergo neutralization with this NaOH. How many times it can undergo neutralization? It can undergo neutralization two times. It can undergo neutralization two times. But if I am participating limited number of NaOH, if I am allowing 1 mole of H2SO4 to undergo neutralization only with 1 mole of NaOH, then one acidic hydrogen, this is called as acidic hydrogen. I will mark it so that you can understand clearly. See, still there is acidic hydrogen left over here. Okay. So because of this acidic hydrogen, this complete salt is called as a acidic salt. Is it understood? Actually, because of the sodium, it is salt. Because of the hydrogen, it is acid. That's why total it is called as a acidic salt. Total it is called as what? Acidic salt. Okay. Okay, now people got doubt about the polyprotic acid. Okay, as I told you, only polyprotic acid can form acidic salt. Okay, so only polyprotic acid can form acidic salt. So before that, you should have idea about the polyprotic. Okay, so let us take H2SO4. Let us take what? H2SO4. The number of proton donating capacity of H2SO4 is 2. Okay, now people have wrong impression. People have wrong impression that okay, now here sulfuric acid donating capacity is 2, so it is more than 1. That's why it is polyprotic acid. Okay. Now, most of the students have wrong option, wrong thinking that like CH3COOH, here four hydrogens are there, so its proticity or basicity must be 4, but its basicity is only 1. Why it is? Okay. So actually, the hydrogen which is directly linked, the hydrogen which is directly linked, okay, directly linked to most electronegative atom. Most electronegative atom you must have studied in the chemical bonding. Okay, you must have studied in the chemical bonding most electronegative atoms. Okay, most electronegative atoms, what are those? Oxygen, fluorine, nitrogen. As a memory technique, I am telling you to remember phone. Okay, most attracting, fascinating object in the world is phone. Same way, most electronegative atoms also phone, FON. Phone means fluorine, oxygen, nitrogen. Okay. So here, let me tell you with one more color. I will choose this green. Okay. So here, this hydrogen only directly connected to oxygen. That's why we will count only this. This hydrogen is not connected with this oxygen, any of this oxygen. So don't count these. Is it understood? So this will come under the monoprotic acid, not poly. Poly means more than one. Protic means proton. Proton means H plus. So it can lose only one H plus, not more than one. Though, so it cannot be counted as a polyprotic acid. It is monoprotic acid. Okay. Sometimes they stay together, but internally they don't stay together, like H3PO3. Okay. So most of the students, what they will do when H3PO3 is given, what they will say, protic, all hydrogens are together, so its basicity will be 3. No, it is not like that. Okay. So with this rule, now you will be able to identify how many hydrogens are able to donate. Okay. So the structure of H3PO3 is this one. Now people start asking, sir, how you will remember this structure? Okay. Are they out of syllabus? My answer is no. Okay. These are in the syllabus, but not in the ionic equilibrium. It is in the P block of the 12th class, 15th group. Okay. Now, question will be framed like this. Here, this structure will be given. Actually, these type of question used to be asked in the very olden days. But if you are not able to understand the olden questions also, then you definitely, suppose this is A. Okay, this hydrogen is B. This hydrogen is C. So now out of these A, B, C, acidic hydrogens, question will be acidic hydrogens are, acidic hydrogen are, oblique is. Okay. Option A, like this they will frame. Very easy to frame the question. Only A. Okay. Option B, A and B. Option C, B and C. And option D will be uh, only C. Okay, these are the options given, I think. Okay, so if you are given like this, you should be able to answer. Okay, so you can think this rule, it should be followed. What it should follow? It should follow that rule. Okay, here. So see this. This hydrogen is directly connected to oxygen, therefore it is acidic hydrogen. This hydrogen is directly connected to oxygen, therefore this is now here it is nowhere connected to oxygen. That's why this is not acidic hydrogen. A and B are acidic hydrogen, so option B is correct. Is that clear? So polyprotic acid, is it understood? Now, can you call this H3PO3 as a polyprotic acid or not? Yes, because two hydrogens are acidic hydrogen. Whenever number of acidic hydrogens are, number of acidic hydrogen means H plus are greater than 1, then such acid will be called as a polyprotic acid. They are called as what? polyprotic acid. Is that clear to all of you? So let me start with the previous topic. Okay. So we have studied in the simple, in the normal salt, acidic salt, then will there will be basic salt. Okay. So basic salt, if you understand the concept of acidic salt, even I need not to teach you about the basic salt. Okay. So this is applicable for the salt whose basicity, sorry, whose acidic nature is more than one. Okay. Like suppose NaOH. NaOH cannot form basic salt. CaOH can form basic salt. See here, calcium hydroxide. This is calcium hydroxide. So when I treat it with only 1 mole of HCl, this hydrogen and Cl will be replaced. Then what it is going to form? Ca. One side it is still Cl, and one side still basic nature is left over. So because of these two, it is salt. Because of this, it is base. So this is basic and this is salt. That's why this is called as a basic salt. Is it clear to all of you? Acidic salt, basic salt. These are three salt I have covered. What are the three salt I have covered? Normal salt, acidic salt, basic salt. Okay. All of them comes under what? Simple salt. All of them come under the simple salt. Okay. So I think all of you noted. If you are not noted, then you can note it afterwards going through the video again. Okay. Then coming to the double salt. Coming to what? Double salt. Don't get confused with the simple salt and double salt. Okay. So here double salt means two salt must be merged together. How many salt must be merged together? Two salt must be merged together. Most important is alums. Okay, alums comes under the double salt only. For example, FeSO4. First example is what? FeSO4. This itself is salt, and it is along with ammonium sulfate, NH4SO4, ammonium sulfate. Okay, dot 6H2O. So this is a best example of double salt. Okay, this is completely one salt only, but internally we find one salt of ferrous sulfate, another salt of ammonium sulfate. That's why this is called as a double salt. Okay. Now when I dissolve this into the water, when I dissolve in water, I will get ferrous ions, I will get ammonium ions, and I will get sulfate ions. Okay. All type of ions I will be getting. That is the advantage of double salt. Okay. Double salt will give the positive test for all ions present in it. Is it understood? So same way we can take another example, Al2SO4. This is a salt of aluminum hydroxide and sulfuric acid. When it is combined with K2SO4, so this is one salt, this is another salt. Combinedly, this will be a double salt, and double salt will be normally associated with some water molecule. Most of them will be 24H2O. Okay, this is called as a water of hydration. This type of formation, what they are called as alums. Okay, so don't worry about this. As I am covering here, it is not final. It is a part of the 13th group also. Okay. So double salt you will study in the alums. About the alums you will study in the 13th group. If you are still, if you wanted to more details about this, there is a playlist about the 13th group. Okay. Everything is specially covered in the 13th group. Is it understood? There you can find out it. Now this is about the double salt. I think double salt is clear to all of you. Now let me start with the next topic. What is the next topic I told you? Complex salt. Complex salt. For this salt only, you have separate chapter that is called as a coordination compound. Okay. But until unless your concepts are clear, not clear at this stage, then it will be difficult for you to study in the class 12th about the coordination compounds. Okay. So complex salt. Complex salt is like FeCN. Okay. FeCN is a salt of. FeCN is a salt of hydrogen cyanic acid, ferric hydroxide. When treated with 4 moles of KCN. Okay. This is one salt. This is another salt. Okay. But when they are merged together, they will form a complex bond. Complex bond means they should have which type of bond they should have? They should have coordinate covalent bond. They should have coordinate covalent bond. Okay. So there will be coordinate covalent bond formation. Then they will form complex salt. If they are not able to form, if they are not able to form coordinate covalent bond, then they will be counted as double salt. Okay. The difference between double salt and complex salt, is it understood? In the double salt, there won't be any coordinate covalent bond between the given two salts. If they are able to form coordinate covalent bond, then there will be, it is called as a complex salt. Now, after combining, we will write it like this: K4 Fe normal bracket Cn6, normal bracket Cn6. Okay. So this is the complete complex salt. Now, as I told you in the double salt, if I dissolve in the water, all ions will be splitting. But here it is not like that. 4 moles of potassium will be separate and all square bracket will be separate. Fe Cn6 4 minus. You will not find Cn minus outside. You will not find Fe2 positive outside. They all will be intact together itself. They all will be intact together itself. Is this understood? So this is about the complex salt. This is about what? Complex salt. Now the very important for the advanced, and if you are aspiring to be a NEET, then if you wanted to be a doctor at AIMS, okay, if you wanted to be doctor at AIMS, or if you wanted to write B Tech in bracket IIT in bracket B, what is B? Bombay. Okay, so then this topic is exclusively for you people. Understood? What is that topic? Mixed salt. What is the topic? Mixed salt. Okay. So if you are not interested about any of these two, or some people are interested in the research field, they wanted to explore the Olympiads. Okay. Or they wanted to write the KVPY. For them also this topic is required. Okay. These are not career options. These are all just taste. They have the passion to be a scientist. For them, Olympiad and KVPI are the best exams. You wanted to be an engineer, it is a profession. You wanted to be a doctor, it is a profession. Okay. So if your profession is this, if your profession is this, if you are passionating to crack the Olympiad or KVPY, then this topic is exclusively for you. Okay. So what is mixed salt? As I told you, in the calcium hydroxide. Okay, calcium hydroxide is a polybasic, polybasic. Okay, two OH are there, and it is not necessary that I will use 2 moles of HCl. So once I will use HCl, another side I will use HOCl. What is HOCl? It is hypochlorous acid. What is HOCl? Hypochlorous acid. Okay. See here, the magic is that why it is called mixed, because we are mixing the two types of acid together. How many types of acid together? Two types of acid. Okay. Here base is only one. Let me select some dark color. Okay. So here it is a base is only one, but acid 1 also mixed and acid 2 also mixed. Okay. Two acids are mixed. That's why the salt in any type of salt formation, common thing, H and OH, and it is not that OH is available, I will take OH. It is not like that. acid and bases are very sincere. They will lose 2 moles of water. Then what they will form? Ca. One side it will be Cl, another side it will be OCl. I think you know its name. Its name is none other than bleaching powder. Okay, bleaching powder is a mixed salt of, it is an example of what? Mixed salt. Mixed salt of calcium hydroxide, hydrogen chloride and hypochlorous acid. What is this? This is hypochlorous acid. Okay, so question will be there, which of the following acid are required for bleaching powder? Okay, hydrogen chloride. This is hydrogen chloride is different. Hypochlorous acid is different. Okay, and calcium hydroxide. Three things are required. One acid is required. One base is required, and two acid are required. That's why this is called as a calcium hydroxide. Calcium hydroxide. So that's why it is called as a mixed oxide. It is a mixture of two acid, one base. If one acid, one base, it is simple salt. Okay, is it understood? So this is about the classification of the salt other than salt hydrolysis. Okay, all of you I think understood now. Okay, as you people are asking one more example. There I have taken base 1 and acid 2. It does not mean that we will take always two types of acid and one base. It can be in the either way also. What is either way? I will take one acid, I will take two base. Okay, one will be KOH, another will be NaOH. Is it understood? So one hydrogen will be removed with the OH of the KOH, another hydrogen will be removed with OH of NaOH. So there will be most positive will be written first K, H, sorry, this will be K, NaSO4. Okay, so this will be example of mixed salt because it is formed because of one acid and two types of base. Is it understood? This is about the another example of the mixed acid. Okay, now by mistake I have written as KHSO4. At least now by this you will be understanding which type of salt it is. First, let me categorize in the, it is what I told you in the first classification. It is whether it is a simple salt or double salt or complex salt. Okay. Question is that whether it is, question was whether it is a simple, double, complex. Okay. Or mixed. It is a simple salt. Okay, in that simple also there are, we have how many types? Three types: acidic salt, basic salt and new acidic salt, basic salt or neutral or normal salt. See here, one more hydrogen is still left over, so in the simple it will be acidic salt only. Okay, simple acidic salt, it is an example of simple acidic salt. Is that understood? Now somebody is asking about complex salt. One more example. Okay. So let us take COSO4, cobalt sulfate. Okay. Is mixed with ammonium sulfate, NH4 twice SO4. Okay. Then if after mixing both of them, what they will form? Ammonia will be outside. Okay. And CO, otherwise I will do one thing, ammonia I will take like this, CO, NH3, 6 and SO4. Okay, so this is also, this is base. Okay, and its sulfate will be outside. That number of moles you can balance it afterwards. So this is also an example of complex salt. Okay, most of the coordinate complexes will be example of the complex salt. Okay.